Now we are continuing into first year functions chapter. Now in this chapter, now our present topic is writing domains. Writing domains of real functions. So we have to choose the domain of a function so that it is a real function. So our heading is write the domains of the following real functions. So under the heading, first problem which we are doing is f of x is equal 1 by x plus 1 into x minus 1 into x plus 3. So we have to write the domain of this real function. Solution, where x belongs to R here. So here f is a real function. As f is a real function, given that f is a real function, implies f of x is a member of R. In real function, both the domain and codomain are subsets of R. That we have already learned when we are discussing its definition, right? So yes, this is a real function where x belongs to R, f of x also belongs to R, because for real function, domain and codomain both are subsets of R. So this implies, what is f of x? 1 by x plus 1 into x minus 1 into x plus 3 belongs to R. So now here you see, if x is minus 1 or x is 1 or x is minus 3, the product will become 0 for any of these three values, for minus 1 or for 1 or for minus 3. This product becomes 0 because 0 and something 0. So when the product is 0, in the denominator you are seeing 0. In the denominator you are seeing 0 means it is undefined. So it doesn't belong to R. So you have to remove those values where our function is becoming undefined. So what are the values that should remove from R? Which is minus 1, 1 is 1 and minus 3. So in order this to be a member of R, so x should not be minus 1, x should not be 1, x should not be minus 3. Therefore required domain is set of all real numbers minus 1, minus 3 and 1. You have to remove. So this all finished, this problem. Now going to the next question. F of x is equal, say another question, root over x square minus 7, where x belongs to R. So now, as f is real function, This implies f of x belongs to R. F of x is root over x square minus 7, belongs to R. This implies in order root over x square minus 7 to be a member of R, the expression lying under the square root sign should not be negative, because negative number square root is an imaginary number. So that is why you should see that this expression is not negative. So it should be positive or 0. So x square minus 7 should be greater than or equal to 0. Did you understand? Then x square is greater than or equal to 7. Implies mod x is greater than or equal to root 7. This implies x is less than or equal to minus root 7 or x is greater than or equal to root 7. Because we have the property that mod x is greater than or equal to k if and only x is less than or equal to minus k or x is greater than or equal to k. If you want, you can note down this property if anybody don't know. So x is less than or equal to minus root 7 or x is greater than or equal to root 7. Therefore required domain is in terms of intervals. If you write minus infinity minus root 7, it is closed interval, union root 7 infinity. So this is a required domain. Understood? This problem is finished. Now coming to the third question, f of x is equal 1 by root over x square minus 9. We have to write the domain. So here f is real function, implies f of x belongs to R. This implies 1 by root over x square minus 9 should be a member of R. So here you should not even allow x square minus 9 to be 0, because if it is 0, in the denominator you will see 0, again it will become undefined quantity. So that should see that x square minus 9 is strictly greater than 0. So this implies x square is greater than 9, implies mod x is greater than 3. This implies x is less than minus 3 or x is greater than 3. So therefore required domain is equal minus infinity minus 3 union 3 comma infinity. Understood? Coming to next question. So f of x is equal 1 by root over 36 minus x square. So f is real function, implies f of x belongs to R, implies 1 by root over 36 minus x square belongs to R. This implies 36 minus x square is strictly greater than 0, implies x square minus 36 is strictly less than 0. This implies x square is less than 36. This implies mod x is less than 6. Implies minus 6 is less than x is less than 6. Therefore, required domain is equal to open interval minus 6 comma 6. Understood? So coming to next question, f of x is equal log 2x minus 3. So f is real function, implies f of x belongs to R, implies log 2x minus 3 belongs to R. See, when your logarithm is not defined, when logarithm of 0 is not defined, logarithm of negative real number is also not defined. Log 0, log of any negative real number or undefined quantities. So, this 2x minus 3 should be now strictly greater than 0. So, this implies 2x is greater than 3. This implies x is greater than 3 by 2. Therefore, required domain is equal to 3 by 2 comma infinity. Did you understand? Now, dear students, in the previous context, we have taken the domains of the real functions. Now, what we are going to do is, we are going to write both domain and ranges of some functions. I have taken here 5 functions on the board. So, for these 5 functions, we are going to write domain and range. Now, let us take the first problem. F of x is equal x minus 2 by 3 minus x. So, f is real function, implies f of x belongs to R, implies x minus 2 by 3 minus x should be a member of R. That means 3 minus x should not be 0. It implies x should not be 3. Therefore, the domain of f is set of all real numbers excepting 3. This is domain. Now we have to write range. So now range. So finding range. So to find range, you have to consider that f of x is equal x minus 2 by 3 minus x is equal to y. Implies x minus 2 by 3 minus x equal to y. Now taking cross multiplication, this implies x minus 2 is equal 3y minus xy. Now this implies x plus xy equal to 3y plus 2 by transposition. So if you take x common, 1 plus y equal to 3y plus 2 implies x is equal 3y plus 2 by 1 plus y. Did you understand? Now here 1 plus y should not be 0, because if it is 0, x is undefined. But here we have seen the domain of the function. What is the domain of the function? We have seen r minus accepting 3. So all real values except 3. But x cannot take an undefined value. So that what you have to do is where 1 plus y should not be 0. Implies y should not be minus 1. Therefore, our range is set of all real numbers minus 1. Understood? So, this first problem over. So, coming to second question. F of x is equal 1 by root over x minus 5. So, f is real function, implies f of x belongs to R, implies 1 by root x minus 5 belongs to R, implies x minus 5 should be strictly greater than 0. You cannot even allow it to be 0. So this implies x is strictly greater than 5. Therefore required domain is open interval 5 comma infinity. Right? Now you have to go for range. So now you see how we will find range. So just now we have seen that x is greater than 5 for range, finding range. Just now we have seen that x is greater than 5 implies x minus 5 is greater than 0. Are you following? So root x minus 5 is greater than 0. As root x minus 5 is greater than 0, 1 by root x minus 5 is also greater than 0. That means y is greater than 0. Therefore, range is 0 comma infinity. Open interval 0 comma infinity. Understood? Coming to next question. So, coming to third question, f of x is equal to x by 1 plus x square. Solution, f is real function, implies f of x belongs to R, implies x by 1 plus x square belongs to R, and here no real number can make the denominator 0. So here for no real number the denominator is 0. So obviously it means that we need not to remove any real value, okay, from R, so that the domain will be entire R. So entire real line will be the domain of this function. Now coming to range. Coming to range, finding range. Let x by 1 plus x square be equal to y. Take cross multiplication. So x square y plus y is equal to x, implies x square y, okay, minus x plus y, right, is equal to 0. This is a quadratic equation in terms of x, okay. So the roots of this equation are real numbers because roots are the values of x. So the roots of the equation are real numbers. So here, as x belongs to R here, the root of this equation is a real number. So therefore delta is greater than or equal to 0. This is delta means discriminant, b square minus 4ac. Are you following? So what is b value? Minus 1. Minus 1 whole square minus 4 into a is y, c is also y. A means leading coefficient, c is here constant, is greater than or equal to 0. This implies 1 minus 4y square is greater than or equal to 0. So this implies This implies 4y square minus 1 is less than or equal to 0. This implies 4y square is less than or equal to 1. This implies y square is less than or equal to 1 by 4. This implies mod y is less than or equal to 1 by 2. Implies minus 1 by 2 is less than or equal to y less than or equal to 1 by 2. Therefore, the range is closed interval minus 1 by 2, 1 by 2. Understood? Now coming to fourth question. So going to fourth question. So fourth question is f of x is equal x square minus 9 by x minus 3. So now f is real function, implies f of x belongs to R, implies x square minus 9 by x minus 3 belongs to R. So this implies x minus 3 should not be 0, the denominator. This implies x should not be 3. Therefore, domain is set of all real numbers excepting 3. Understood? So now range. So to find range, x square minus 9 by x minus 3 say equal to y, implies x square minus 9 is 3 square by x minus 3 is equal to y, implies x plus 3 into x minus 3 by x minus 3 equal to y. X minus 3 get cancelled, x plus 3 is equal to y, whereas x not equal to 3. It means y is not equal to 6. Why x not equal to 3? Previously we have seen in the domain x is not equal to 3. When x is not 3, y is obviously it is not 6. Therefore range is equal set of all real numbers excepting 6. So we have written range. And last function, our fifth function, or fifth problem is f of x is equal 1 by 2 minus sine 3x. This is a problem. solution f of x is real function implies f is real function implies f of x belongs to R. This implies 1 by 2 minus sine 3x belongs to R. This implies 2 minus sine 3x should not be 0, isn't it? And there is another alternate, no other alternate. This should not be 0. That means sine 3x should not be equal to 2, right? But sine 3x maximum value only 1. So sine 3x can never be 2 for any x. So no possibility sine 3x to be 2 anyhow. So sine 3x maximum value is 1. So sine 3x will never be equal to 2. Okay? So for any x belongs to R. Therefore, domain is equal R. As sine 3x is always less than or equal to 1. Sine 3x maximum value only 1. So, no real number x can make sine 3x 2. So, need not to remove any value. So, you can take all the real numbers. So, the domain is R. So now finding range. See here, we know that always sine 3x lies between minus 1 and 1. So now if you multiply with negative 1, 1 is greater than or equal to minus sine 3x is greater than or equal to minus 1. Right? Now if you add 2 everywhere, 1 plus 2, 3 is greater than or equal to 2 minus sine 3x is greater than or equal to 2 minus 1, 1. Right? If you take reciprocal, 1 by 3 is lesser than or equal to 1 by 2 minus sine 3x is lesser than or equal to 1. And this is nothing but our y. So, 1 by 3 is lesser than or equal to y is lesser than or equal to 1. Therefore, the range of the function is closed interval 1 by 3, 1. Understood? Right.